Okay, ladies and gentlemen, we have a area of triangles that we need to deal with. The first and most basic type of area of a triangle would be a right triangle and use 1/2 b times h. So if I had something as follows, I had 6, I had 10. With a right angle here, the base is 10, the height is 6, so I'm going to say 1/2 of 6 times 10. Answer is 30. Very easy. Now, if you have this triangle, the large triangle, it is not a right triangle, and to use 1/2 BH I have to drop an altitude right down the middle. By dropping an altitude down the middle, I need to find the height. Now, I can't use the 11 because the 11 is for the entire side. But I have a 7 over here, and as long as I know one angle, I can use my trig functions to find the missing piece. So let's find the height here. I have angle, I have opposite, I have what would be the hypotenuse of this triangle here. So, we're going to say sine of 24 equals h over 7. So I'm going to multiply both sides by 7. And now all I have to do is say 7 times sine 24, and I get 2.85. So now that I have the height of the triangle, I can say 1/2 base, which is 11 for the whole triangle, height of the whole big triangle, 2.85, and go from there. So 2.85 times 0.5 times 11. And I get 15.65. And that would be feet squared, units squared, whatever it happens to be squared. So 15.65. Now that's fine, except I had to, before I use this formula, go over here and find its height. Well, the thing about it is, can't we just take these two formulas and put them together? The answer is, well, yeah. Area equals 1/2 BC sine A. In this case, if I were to label this triangle, I would have angle A, which is sine 24. I would have side B, which is 11. I would have side C, which is 7. And I would have the 1/2. So I have the 1/2, 11, just like I have up here. And then I'm going to have 7 times sine 24, just like out of the other formula from over here. So by putting all that together, I can find the area in short order. So, not too hard to do there. Anytime you have a side angle side situation, you can use this formula. Now let's say I had this angle and this angle. Well, I could simply find the missing angle and do it that way. But there is another situation we need to deal with. Okay, so the other situation that we have is where you have a side-side-side situation. A side-side-side situation, I have no angle, so I cannot find this height because I don't have any angle to begin working from like I did on the first page. So, I need a hero, better known as a hero's formula or Heron's formula, depending on which book you're looking at. And his formula is the square root of s times s minus a times s minus b times s minus c. Now, what's s? S is a semi-perimeter. So just like a semicircle is half a circle, a semi-perimeter is half a perimeter. So I would take side plus side plus side, which in our case would be 5 plus 7 plus 11, and divide it by 2. So if I do that, I come up with 5 plus 7 plus 11, enter, divide by 2. I come up with S equals 11.5. So now I just have to create my formula. So let's bring the formula, let's bring the semi-perimeter, and we say square root of 11.5 parenthesis 11.5 minus 5, 11.5 minus 11, and 11.5 minus 7. With that, you come up with 11.5, you come up with 6.5, come up with 0.5, and you come up with 4.5. Multiply and square root. In this case, I come up with 12.97. Now, you say, well, that doesn't match what you got on the other page. Well, just because I happen to use the same 11 and the same 7 doesn't mean that these two are the same triangle. I could have used any numbers I want. In fact, with this being so small, this and this make 12. This is going to be even smaller than 24 degrees. Which, by the way, how could you find this angle right here, or this angle right here, or this angle right here, given this situation? Okay, that is finding angles. That is finding angles and areas and heights for triangles. So I think that finishes up our law of sines, law of cosine section.